sodium chloride, beaker on, (50.4490) tare 0. Five grams of sodium chloride, on a third beaker. There. 5.0086. The ionized water, I need 45 grams of. (50.0980). Small beaker, about 15 milliliter, 20 milliliter size. Mass of beaker 12.9015. Tare. A 10 milliliter pipette. I need 10 milliliter of the solution. Empty the air in the pipette and pour up the liquid. The bottom of meniscus should be on the line. Press empty. All done. Those 10.6890 mass of salt solution. Okay, 0, 100 milliliter beaker. On the balance, screen closed, it reads 66.0252 grams. Tare 12.5 grams. .47, so that's close enough. 12.4745 grams of copper sulfate, copper 2 sulfate pentahydrate. Copper 2 sulfate pentahydrate, about 12.5 grams, and about 30 milliliters of water. This is the ionized water. A magnetic stirrer. A little bit of heat, about 100, and stir. So turn on the magnet on about 250 RPM and a little bit of heat and wait. Retrieve the magnet using magnet retriever. Just a quick squirt to rinse off any copper 2 sulfate pentahydrate. Transfer solution into volumetric flask. 50 milliliter volumetric flask, a funnel to facilitate transferring of the liquid. All of the liquid goes in. And a quick rinse to get the rest of the liquid in. Add water to make it to the line. Here, right there. Once you get to the narrow part, add water drop-wise. A few more drops. Put the stopper on. And I'm holding on to the stopper and tap to get any bubbles out, just to make sure the bottom of meniscus is still on the line. Transfer about half of this into a beaker. You only need to keep a little bit of it. Now put it to the side. A 25 milliliter pipette and fill up to the line. To 5 milliliter. If you took that off safely, then it's a little bit quicker. Transfer all of the liquid into another 50 milliliter volumetric flask. So don't blow out anything. There's going to be a little bit left, but that's okay. Add the ionized water to make it to the line, to make 50 milliliters. Invert and mix. Transfer into another beaker. So far, 1 molar dilution, the original batch, 0.5 molar dilution, which I have in here, going to make 0.25 molar dilution. So using 25 milliliters again. Putting it into a 50 milliliter volumetric flask. So the pipette emptying out. The last drop done. Using the ionized water to make it to the line. add the last few drops using a dropper. Water in a beaker using a dropper. Okay, stopper, invert and shake. Make sure it's all well mixed. So this is my 0.25 dilution. I'm going to make a 0.1 molar dilution. Based on my calculation, I need to take 20 milliliter of 0.25, transfer into a 50 milliliter volumetric flask to make 0.1 molar. Transfer most of it here, and 20 milliliters. So I'm just going to put my pipette in there and allow the liquid to transfer into the last volumetric flask. This is my last dilution, and it's going to be 0.1. When I make it to the line, I make 50 milliliters. Using a dropper, okay, and last stopper, mix well. Make sure the volume is right. We have the spectrophotometer here, and we have cuvettes, 4 of them for 4 solutions. The spectrophotometer should be on the wavelength of 600 nanometer, and the absorbance should read 0. There's also a blank in here, B, that when you press it, it will 0 it. Let's fill up the cuvette. So each cuvette would get filled up with 1 solution, and we try not to cross-contaminate. You fill it up to the line. It doesn't matter if it goes higher than the line, but it shouldn't be below the line, because the light passes down here. So you want the liquid to be there. So that's 1 molar. This is 0.5 molar, 0.25, and 0.1. So 5 solutions in here, 1 molar, 0.5 molar, 0.25, 0.1. The last one is an unknown. Here I have 600 nanometer as wavelength. I have a blank cuvette in here which contains just a glass and water, so that zeroes any background reading due to water and the glass. Then I'm going to use tissues to wipe each of these and put them in order. The reason I wipe the bottom of the test tube is just because I don't want any fingerprint or anything else that might absorb the light. So putting them in the order of 1 molar to 0.1 molar, and then the last one is the unknown. Close, press blank to make sure it's 0 for blank, which is 0 absorbance. Now I'm reading 0 absorbance at 600 nanometer. I'm pressing 1, which is the 1 molar solution, and reading 0.875 A, which is absorbance. So for 1 molar is 0.875. For 0.5 molar is 0.435. For the third solution, which is 0.25 molar, 0.243 A absorbance. So 0.243 A for 0.25 and for the fourth dilution, which was 0.1 molar, I'm reading 0.088 A. So the A stands for absorbance because that's what we're reading. So solution 5 was the unknown and is 0.127. So the absorbance for the unknown is 0.127, and that's it.